This is Higher Maths. We're looking at straight line topic and we're looking at perpendicular lines. Perpendicular lines will be lines that meet at right angles, and there's a diagram that I've got that I've plotted for the question that I'm going to go and do. So what I can see here is that these lines here are meeting at right angles, and what I've got to do when I'm trying to look at perpendicular lines, I'm trying to prove that the lines are perpendicular and that they are at 90 degrees to each other. And the way that I'm going to do that is through working through gradients. And when I work out the gradient of A to C and the gradient of A to B, if I multiply the two of them together, I should result in a -1. And if that property exists, then I can state that the lines are perpendicular. Let's go ahead and do this first question, and I'll give you some other questions to look at after this one. So first of all, what we're going to do is we're going to plot the points and then find the gradients of the lines joining AB and AC. Okay, I've already plotted them just for a bit of quickness, and what I'm going to do is I'm going to work out the gradient of AB first of all. So let's go for the gradient of AB. What I'm going to do is I'm going to use the y2 minus y1 all over x2 minus x1. From there I've got, let's go for it, so minus 2, subtracting 1, I've got 0, subtracting minus 2. From there on the top I can see that that's minus 3, and that's going to be over 2. Okay, so that's the gradient of AB. Let's now work out the gradient of AC. So the gradient of AC, I'm just going to use the same formula, y2 minus y1 over x2 minus x1. Okay. And what I'm going to do is for here, and it's AC that I'm working on, so it's going to be 3 take away 1 and 1 take away minus 2. What I've got there is 2 on the top, and on the bottom there in the denominator I'm going to have 3. So the two gradients I've got, gradient of AB minus 3 upon 2 and the gradient of AC 2 upon 3. Right, let's see if this property exists to see if these do meet at right angles. So what I'm going to do is I'm going to multiply the gradient of AB, times it by the gradient of AC, and hopefully I'm going to get -1 coming out as an answer for that. Right, so what we've got here is we've got minus 3 upon 2 for the first gradient. I'll times it by 2 upon 3, and when I times them across the way I've got minus 6 on the top, and 2 times 3, 6 on the bottom. To simplify that out, I just get -1. So this property now exists for these two lines, and what I can say is that since I've got the gradients of gradient AB times the gradient of AC, since that equals -1, I'm going to say that AB and AC are perpendicular, or basically that they're at right angles to each other. And that's really what we're trying to prove in what we're doing here. Right, so what I've got here is I've got some questions for you to do after this. Okay, just following the same format, work out the two gradients. You don't really need to plot the diagram. Be good to do one of them just so you can see that they are at right angles to each other. And I'll give you these questions here. So what you can do is freeze the video and work through these questions here and show that they are perpendicular or not. Right, so what else we can do here is I've got some further questions for you to do, and then I want to just talk to you about a simple way of finding a perpendicular gradient. So some further work that you can do from the textbook, looking at parallel and also perpendicular lines, would be to look at page 5. It's on exercise 2b, and if you go for question 1 to 3, there's some basic questions on parallel and perpendicular lines using gradients. Page 7, exercise 3, a bit of a basic understanding of it, and then we're getting into some different parts that we would use the perpendicular or parallel lines for. So for question 4 and 5, we'll be using y is equal to mx plus c equations, and we'll be trying to work out gradients from there. Lines at right angles, so the perpendicular from question 6. Missing coordinates in question 7. Proving right-angled triangles using Pythagoras theorem and a bit of the distance formula in question 8. Proving some shapes, proving a shape as a rectangle. Proving that we have an isosceles triangle, and further some circle problems in question 11. So all of these questions would be good to attempt to make sure you have a good understanding of the use of parallel and perpendicular lines. Remember, for parallel lines, gradient 1 is equal to gradient 2, so the gradients are exactly the same. For perpendicular lines, gradient 1 times gradient 2 must equal -1. If they don't equal -1, they're not perpendicular. Even if it's really close, they're still not perpendicular. It must be -1. Right, just if I can show you a kind of simple way to find out some perpendicular gradients. So let's go for it. So, simple way to find perpendicular gradients. Right, so let's see. If gradient 1 was equal to 1/2, then straight away what I could say is that the perpendicular gradient, so I've just got a wee right angle sign there, perpendicular gradient is going to be equal to, what I'm going to do is I'm just going to flip this fraction over and I'm going to change the sign, just similar to what you would do when you're dividing out fractions. So flip it over, so it's going to be 2/1, and it's a positive there, so I'm going to make it a negative there. So that there is going to be, the two are going to be perpendicular to each other. So simplifying that out, that'll just be -2. So a gradient of 1/2 and a gradient of -2, these are going to be perpendicular. Let's look at another example. So if the gradient 1 is going to be equal to -4/3, a perpendicular gradient is going to be, flip it over, 3/4, and change the sign to a positive. So that's going to be 3/4 is going to be that gradient there. So they're going to be perpendicular. If I've got a gradient of 5, okay, just a whole number, what I'll think about is that 5 can be written as 5/1, and the perpendicular gradient to that will be, flip it over, which will be 1/5, and change the sign, so that'll be -1/5. So remember, whenever you do this kind of simple kind of method of using it, what you'd be required to do is to make a statement, and the statement would be in bracket. It would be, since gradient 1 times gradient 2 equals -1. So that's how you know how to get that, that other fraction that's here for the perpendicular gradient. So that's quite a simple way of doing it. Alternatively, what you can do is you can do the work for it. So gradient 1 times gradient 2 is equal to -1. So if I take this example here and try to do that one, for gradient 1 it's 1/2, and I know if they're perpendicular, then what I should have is them equaling -1. So to work out the gradient 2, what I'll do is I'll multiply by 2 and divide by 1, if that's the fraction that's there. So that will give me -2/1, which gives me -2. So just using the property of a perpendicular gradient. Okay, so a very simple way, as I say, just flip the fraction over and change the sign. Okay, would be an easy way to finding perpendicular gradients. Hope this has helped, and I hope that you complete the questions that are in the textbook, and good luck on parallel and perpendicular lines.